In this tutorial, we will briefly review averages, the range, and standard deviations. This review will be brief since these topics should have been covered in a statistics course. We are reviewing them because they are the basis of X-bar, range, and S-control charts. The slide shows a set of data that is typical for the data used to construct control charts. In this case, it is the diameter of holes drilled by an industrial drill press. Each row represents a sample, so there are 6 independent samples. Each sample has 4 observations in it. Be careful not to confuse the two. When we talk about sample size, represented by the letter N, we are talking about the number of observations in each sample. In this case, the sample size is 4. The sample size of 4 is what we will use to look up numbers in the table of control chart factors. There are 6 different samples. While not used for control charts, in statistics the number of samples is represented by the letter K. To find the mean, of course, we add up the numbers on the row and divide by 4. For sample number 1, 0.41 plus 0.56 plus 0.57 plus 0.41, all divided by 4 equals 0.49. For sample number 2, 0.43 plus 0.46 plus 0.47 plus 0.43, all divided by 4 equals 0.45. For sample number 3, 0.45 plus 0.41 plus 0.52 plus 0.61, all divided by 4 equals 0.50. For sample number 4, 0.50 plus 0.51 plus 0.47 plus 0.53, all divided by 4 equals 0.50. At this point, why don't you pause the video and work the last two on your own before restarting the video. For sample number 5, 0.58 plus 0.55 plus 0.52 plus 0.60, all divided by 4 equals 0.56. For sample number 6, 0.59 plus 0.49 plus 0.41 plus 0.49, all divided by 4 equals 0.50. The range is just the largest observation on a row minus the smallest observation on a row. For sample number 1, 0.57 minus 0.41 equals 0.16. For sample number 2, 0.47 minus 0.43 equals 0.04. For sample number 3, 0.61 minus 0.41 equals 0.20. For sample number 4, 0.53 minus 0.47 equals 0.06. At this point, why don't you pause the video and work the last two on your own before restarting the video. For sample number 5, 0.60 minus 0.52 equals 0.08. For sample number 6, 0.59 minus 0.41 equals 0.18. As a general rule, operations management textbooks do not require you to compute the standard deviation. Rather, on problems that require the standard deviation, they give it to you. Nevertheless, we will briefly review the standard deviation in case you are asked to calculate it. Since we will need it for these calculations, I have included the means that we calculated earlier. For sample number 1, the square root of the quantity, 0.41 minus the mean of 0.49 quantity squared, plus 0.56 minus 0.49 quantity squared, plus 0.57 minus 0.49 quantity squared, plus 0.41 minus 0.49 quantity squared, all divided by 3 equals 0.090. For sample number 2, the square root of the quantity 0.43 minus the mean of 0.45 quantity squared, plus 0.46 minus 0.45 quantity squared, plus 0.47 minus 0.45 quantity squared, plus 0.43 minus 0.45 quantity squared, all divided by 3 equals 0.021. For sample number 3, the square root of the quantity 0.45 minus the mean of 0.50 quantity squared, plus 0.41 minus 0.50 quantity squared, plus 0.52 minus 0.50 quantity squared, plus 0.61 minus 0.50 quantity squared, all divided by 3 equals 0.088. For sample number 4, the square root of the quantity 0.50 minus the mean of 0.50 quantity squared plus 0.51 minus 0.50 quantity squared plus 0.47 minus 0.50 quantity squared plus 0.53 minus 0.50 quantity squared, all divided by 3 equals 0.025. At this point, why don't you pause the video and work the last two on your own before restarting the video. For sample number 5, the square root of the quantity 0.58 minus the mean of 0.56 quantity squared plus 0.55 minus 0.56 quantity squared plus 0.52 minus 0.56 quantity squared plus 0.60 minus 0.56 quantity squared, all divided by 3 equals 0.035. For sample number 6, the square root of the quantity 0.59 minus the mean of 0.50 quantity squared plus 0.49 minus 0.50 quantity squared plus 0.41 minus 0.50 quantity squared plus 0.49 minus 0.50 quantity squared, all divided by 3 equals 0.074. This slide shows a summary of the values we just computed. With these values and knowing the sample size was 4, we could prepare the X-bar, R, and S charts without having access to the raw data. If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.